In this next question, we're going to looking at question 3.15. In this question, it's slightly more challenging than the previous one because of the existence of this voltage source here. Now, if you're looking at my node analysis strategy, in the second step, we need to somehow represent voltage source in node voltage. And when it's come to this particularly voltage source in this question, well, if we choose the ground node smartly, it actually can help us to simplify this problem. Well, specifically, let's look at how many nodes are here. Nodes are the point of circuit that's connecting more than 2 or more elements. And in this question, we actually have 4 nodes. Those are this one, node 1, 2, 3 here. And the first one is at the bottom. And in this case, I'd like to choose the bottom node as my ground. The advantage of choosing this bottom node as my ground is that I'm directly connecting this voltage source to the ground, or I'm choosing one of the terminal of the voltage source as the ground. This will allow me to easily route the node voltage of the other terminal for this voltage source. So when you think about this, we know the voltage difference between this voltage source is 6 volt. And once I determined one terminal is 0, the other is either positive 6 or negative 6, depending on the polarity that you choose for your reference direction. So then I'm going to apply, again, firstly, my first node analysis strategy, and with the combination of the second step, representing voltage source in node voltage. Well, coming to my first node here, again, I'm going to assume current leaving node 1 as my reference direction. So for this V1, I have at the top branch V1 minus V3. This is the current going through the top branch. And for the bottom one, well, I'm choosing the opposite direction of the current source, so it's a negative 4 milliamp. And for this branch, I have V1 minus V2 divided by the resistance 1K. And the algebraic sum of this is 0. So this is at the first node. For the second node here, actually, because I'm choosing one of the terminal of this voltage source as my ground, I can easily write V2 equals negative 6. Well, the reason for this is that when you're looking at the voltage source, the positive terminal of this voltage source are being chosen as the ground. So here it needs to have the other terminal should have a lower voltage potential. In fact, it's 6 volt lower. So 6, this part I'm choosing at 0, 0 minus 6, that end up with V0, V2 as negative 6 volt. Or you can try to write the voltage difference across your voltage source according to its polarity. So this one is equivalent to say that 0 minus V2 equals 6, right? So this is the node voltage for the positive terminal. This is the node voltage for the negative terminal. And again, you can easily see that these two are equivalent. So when you have more experience writing this, you can directly come up with the voltage across your voltage source if it's been connected to the ground. Well, then moving to the next node, at node V3, I have, again, starting with the top branch, V3 minus V1. And for the middle branch, I have V3 minus V2. This is a 2K direct resistor. And this time current is leaving, so minus 2 amp equals 0. So now I have 3 linear equations, which are independent, and have 3 unknown variables. V1, V2, V3. I can easily solve all of my node voltage. But the attention needs to be paid for this question in particular is that I'm asking for the I0, the current that goes through this 2K resistor here. So after writing out all of my node analysis strategies and finding my node voltage, we're not done here. So to solve or to answer the question of I0, I apply the simple Ohm's law here. So notice the reference direction of the current is from left to right. So this should be V2 minus V3 divided by the resistance. And with this, you can solve the question.